Hi friends, in this video we are going to discuss about the concept of nodal analysis. So here the main purpose of nodal analysis is if you want to find the voltages, those are unknown voltages at any node point. So with the help of this nodal analysis we can easily find out those unknown voltages at each node. And here whenever we are going to applying this nodal analysis in any circuit, so first we need to observe how many nodes are there. So in this given problem we are having two nodes. So here this one is one node and this one is another node, and I am giving the names for these voltages. For node 1 is V1, for node 2 is V2. Now we don't know about the exact values of V1 and V2 at these node points. Now if you want to find these voltages, these unknown voltages at node 1 and node 2, so it is mandatory to apply nodal analysis only. Without applying nodal analysis concept, it is not possible to find the voltages at individual nodes. Now the most important point is, if you want to apply nodal analysis means you have to take the help of Kirchhoff's current law, that is KCL, because if you want to find the value of V1 and V2, so you need to apply the Kirchhoff's current law at each node. If you are applying Kirchhoff's current law at each node, then you will get equations. And here, for example, you are applying Kirchhoff's current law at node 1 means you will get one equation, and you are applying KCL at node 2 means you will get another expression. Here number of equations is equal to number of nodes. It means what? How many nodes are there, you will get that many number of equations. Okay. Now this is point number 1. Here the number of nodes is equal to number of equations, and here we are going to apply KCL at each node. Now point number 2 is, whenever we are applying KCL at this particular node 1 and node 2, the most important point is, when we are applying KCL at node 1, the directions of currents always outgoing from this particular junction point. Okay. Now what I am doing, I1 is the current which is flowing in R1 resistance, and I2 is the current which is flowing in R2 branch resistance, and I3 is the current which is flowing in R3 branch resistance, and these three currents are outgoing from this particular junction point. Okay, this is the most important step. Whenever we are applying nodal analysis in any given circuit, so if you are applying at node 1 and node 2 means the directions of currents always outgoing from the given from this junction point 1 and 2. Now here I1, I2, I3 are the outgoing currents from this particular junction point 1, and coming to junction point 2, now I am taking I4, and this one is I5, and this one is the I6. Now I4, I5, I6 are the currents which are outgoing from junction point 2. It means in order to find the unknown voltages V1 and V2, we need to apply KCL at KCL at node 1 and KCL at node 2. Now we are applying means you will get two expressions. By solving those two expressions, you can easily get the value of V1 and V2. Okay. Now before I am going to applying nodal analysis for this particular circuit, I am going to draw the separate diagrams for node 1 and node 2, because if you are good in the network separation, then you can easily apply KCL and get the expression from node 1 and node 2. Now here coming to the node 1, I am drawing the separate diagram for node 1. Node 1 means, for example, so this is node, you can assume, and the name of the node is V1 for example, and how many elements which are connected to node 1, so we have to consider all those elements. Okay. Now just see here, so just see here, R1 is equal to 10 ohms is R1 is equal to 10 ohms, and R2 is equal to, this one is 10 ohms, and here R3 is equal to 30 ohms. Now here the value of applied voltage is 100 volts. Okay, now we know that the currents outgoing from the node 1 are I1, I2 and I3. Okay, now this is a separate diagram for what? Node 1. Now see here, for node 1, R1 is connected, R3 is connected, R2 is connected. Now all these three resistances are connected to here, and in case of R1 branch we are having voltage source. So this voltage source connected in series with the R1 resistance. So that is the reason why we are directly taken the complete branch including the voltage source, and like this we have drawn. Now what we need to do, just apply Kirchhoff's current law at node 1, then you will get what? You will get one expression. Okay, now see, apply KCL at node 1. So we know that the definition of Kirchhoff's current law is sum of incoming currents must be is equal to sum of outgoing currents. It means we do not have any incoming current to this particular node 1, but we are having outgoing currents. Those are I1, I2 and I3. So that is the reason why 0 is equal to I1 plus I2 plus I3. Now coming to the actual concept, that is I1 is the current which is flowing between V1 and 100 volts. Just see here, I1 is the current starting from node V1 and which is directly flowing, and 2 watts 100 volts is flowing through what? R1. That is the reason why instead of I1 we can directly place V1 minus 100 divided by the value of R1 plus I2. I2 is the current which is starting from V1 and it is directly flowing through R2 and completely it is towards the ground. So that is the reason why I2 is equal to V1 divided by R2. Next, plus I3 is the current starting from V1 and which is flowing towards V2 through resistance R3. Okay, just see here, which is flowing between V1 and V2 and through what? R3. That is the reason why V1 minus V2 divided by R3. Okay, now simplify. Now first we need to substitute the value of all the resistances in this expression. Now value of R1 is 10 plus V1 divided by value of R2 is also 10 plus V1 minus V2 divided by R3 is 30. Okay, now here 0 is equal to, I am simply writing here like this, V1 divided by 10 minus 100 divided by 10 plus V1 divided by 10 plus V1 divided by 30 minus V2 divided by 30. Okay, just I am splitting the each term like this, and after that just go for the simplification. Now see, so we got the expression that is 0 is equal to V1 divided by 10 minus 100 divided by 10 plus V1 divided by 10 plus V1 divided by 30 minus V2 divided by 30. Just I am writing this expression from the last step of this page. Okay, now see, same expression I am writing here for the simplification purpose. Now see here, 0 cancel, then the remaining terms are, so 0 is equal to, so V1 divided by 10. V1 divided by 10 means, so V1 into 1 by 10. 1 by 10 how much? So 0.1 and into V1. Okay, so 1 by 10 I am writing like 0.1 into the value of V1 minus, so 100 divided by 10 means you will get 10 plus V1 divided by 10 means you will get again 0.1 into V1 plus 1 divided by 30. 1 divided by 30 means you will get 0.033. This one is V1 minus again V2 divided by 30 means you will get 0.033. This one is V2. Okay, now here minus 10 is there and this minus 10 I am bringing this side, then 10 is equal to 0.1 V1 plus 0.1 V1 plus 0.033 V1 minus 0.033 V2. Now just here 0.V1, 0.V1 and 0.033V1. Just common or take common V1 from these three terms like this. So we are taking common, that is, so V1 we are taking common 0.1 plus 0.1 plus 0.0, so 33 minus 0.033 V2. Okay. Now by simplifying, that is 0.1 plus 0.1 plus 0.033, it will gives the value as, so G10 is equal to V1 into, it will gives a complete value as 0.233 minus 0.033 V2. Okay. Now I am assuming this is equation number 1 we got from the actual circuit, that is this one. Okay. Whatever the circuit we have drawn for the separate node 1, so from this expression, from this network, we are applying KCL and we are getting the expression like this. Okay. Now coming to the second node network. Now from this network I am drawing separately for the node 2. It means whatever the elements which are connected to node 2, I am considering all those elements and I am separately drawing that particular network like this. Now see here, so node 2, I am talking about node 2 now. Now node 2, what is the circuit? So here this is a V2, and for this V2 we are having one resistance connected, that is R5 is equal to 50 ohms is connected, and from this we are having another resistance branch, so that one is connected, that one is the value of R4 is equal to 40 ohms, and here the value of another resistance which is connected, that is the value of R3, that is equal to, so 30 ohms, and this one is V1. Now this is a circuit we have drawn from the actual circuit, and we are drawing this circuit for only node 2. That is the reason why the elements which are connected to node 2, those are R3, R4, R5, and we are simply taking this complete part we are drawing here. Okay. Now we know that the current flowing through this R3 is I4, this is I5, and this one is I6. Okay. Now again same. Now we know that the direction of currents always outgoing from the junction point whenever we are applying nodal analysis, and I4 is the current which is starting from V2, and this I4 is flowing through R3 towards V1. I5 is the current starting from node V2 and which is flowing through R4 towards ground, and I6 is the current which is starting from V2 and which is flowing through R5 and towards flowing to ground. Now same, apply KCL at node 2. Okay, apply KCL at node 2. Now there are no incoming currents, so that is the reason why sum of incoming currents are 0, outgoing currents are I4 plus I5 plus I6. Now 0 is equal to I4. I4 means current starting from V2 and which is flowing through R3 towards V1. It means instead of I4 we are placing V2 minus V1 divided by R3 plus I5 is the current starting from V2 flowing through R4. So here, so V2 divided by R4 plus I6 is the current starting from V2, that is node 2, and flowing through R5 towards ground. So here V2 divided by R5. Okay. Now 0 is equal to, so V2 minus V1 divided by R3 means 30 ohms plus V2 divided by R4 means 40 ohms plus V2 divided by R5 means 50 ohms. Now here what I am doing, just I am splitting here. So 0 is equal to, so V2 divided by 30 minus V1 divided by 30 plus V2 divided by 40 plus V2 divided by 50. Okay. Now again simplify this one. 1 by 30 will gives one value into V2. Like this we need to simplify. Just see here we are simplifying this expression. Now this point is, from this also we are going to get one expression. After getting this expression, just to simplify equation number 1 and 2, you will get the value of what? final unknown voltages V1 and V2. Now see here, the final expression we got, that is 0 is equal to V2 divided by 30 minus V1 divided by 30 plus V2 divided by 40 plus V2 divided by 50. So this is the expression we have taken in the last step of this page. Same thing I am writing here for calculation. Now 0 is equal to 1 by 30. This is V2 divided by 30 means, so V2 into 1 by 30. 1 by 30, it will give the value as what? 0.033 into V2 minus again 0.033 V1 plus, so here 1 divided by 40, it will give the value as 0.025 into V2 plus 1 divided by 50, it will give the value as 0.02 V2. Okay, now here V2 term and V2 term is common, so that is the reason why 0 is equal to take V2 common from the three terms. So here V2 we are taking common, 0.033 minus 0.033, sorry, this is 0.025, sorry, so a complete expression I am removing this one. So 0 is equal to V2 take common, so here 0.033 plus another V2 is there, that is 0.025 plus the last term, that is 0.02 minus 0.033 V1. Okay, now simplify this complete term, that is 0.033 plus 0.025 plus 0.02, it will gives the value as 0.078 minus 0.033 V1. Okay, now this is the expression. Now what I am doing in the equation number 1, we are having, so from here, just see here, this is the equation number 1. Just observe this equation, 10 is equal to V1 into some value minus G some value into V2. Now what I am doing from equation number, otherwise we can consider this is equation number 2. Now from equation number 2, I am writing the expression of V1 in terms of V2. It means what? From this expression, just see here, you can easily get the solution by substituting this value. Now from equation number 2, so V2 into 0.078 is equal to 0.033 V1. Now from this expression, what I am doing, I am writing the expression of this one. So V1 is equal to 0.078 divided by 0.033 into V2. Okay, now here, so 0.078 divided by 0.033, it will gives the value as, so V1 is equal to 2.3636 V2. Okay, now this is the expression of V1 in terms of V2. Now assume this is equation number 3. Now finally we got the expression number 3, that is V1 in terms of V2. Now substitute this equation number 3 in equation number 1. Okay, so this is the equation number 1, we know. Now this, in this equation, that is instead of this V1, we can directly substitute the value of V1 in terms of V2. Okay, now see this expression from equation number 1, we are having the expression, that is 10 is equal to 0.233 V1 minus 0.033 V2. This is the expression of equation number 1. Now what is the expression of equation number 3? V1 is equal to 2.3636 V2. Okay, now the expression number 3, expression number 3 is V1 is equal to 2.3636 V2. Now this is equation number 3 and this is equation number 1. Now substitute this value in equation number 1. Now from equation number 1, we can say that 10 is equal to 0.233 into, instead of V1, I am directly substituting 2.36 0.36 into V2 minus 0.033 V2. Okay. Now like this we are substituting the value. Now 10 is equal to, so here the value of 0.233, 2.3636, it will give the value how much? So 0.233 into, so 2.3636, it will give the value as 0.5507 into V2 minus 0.033 into V2. Now here from this expression, that is from this equation 0.5507 V2, I am subtracting this value 0.033. Now that is 0.5507 minus 0.033. It will give the value as 0.5177 into V2. Now from this we can write V2 is equal to 10 divided by 0.5177. Okay. Now if you are simplifying this one, so 10 divided by 0.5177, it will gives the value of V2 is equal to 19.3162 amp. This is ohms. Okay. Now this is in ohms. So V2 is equal to 19.3162 ohms. Now finally we got the expression, value of V2 is equal to 19.3162. Now assume this is equation number 4. Now what we need to do to get the value of V1, just substitute this equation number 4 in equation number 3. Okay. Now what is the equation number 3 actually? The equation number 3, it will gives this one only now. So V1 is equal to 2.3636 into V2. Now from this, so V1 is equal to 2.3636. Instead of V2, I am directly substituting, that is 19.3162. Okay. Now here by multiplying, that is 2.3636 into 19.3162. It will gives the value of V1 is equal to, so 45.6557 volts. Okay. The units of voltage is always in volts only. So finally we got V1 is equal to this much and V2 is equal to 19.3162 volts. Okay. So by using the concept of nodal analysis, we are going to find the unknown voltages V1 and V2 from the given circuit. Okay, from the given circuit. Those are what? So this value we calculated now, and this value we calculated now. Okay. So like this we need to proceed to calculate the unknown voltages available at each node. Okay. Thank you so much for watching, and please do subscribe my channel for more updates. Thank you.